now we're trying to solve a problem, and we're going to use this using vectors and a vector diagram and then some basic math skills. So on a summer day, a person goes for a walk to see if they can find a 7-Eleven to buy a Slurpee. He first walks 3.5 kilometers north. So let's draw that. 3.5 north. Then he goes 4.2 kilometers east. It's a little bit longer east, tip to tail right here. 4.2 east. And finally, 1.4 south. Okay. What is the displacement? So this is where he started. This is where he finished. There is his displacement. Okay, so we want this to look like a triangle. So what I'm first going to do is we can add vectors in any order. I'm first going to add the collinear vectors, the 3.5 and the 1.4. So if I have 3.5 north and I add 1.4 south, really my resultant, or all that's left, is just going to be 2.1 kilometers north. So I'm going to change my diagram. It only goes up to 2.4 north. So my new diagram looks like 2.4 north, then 4.2 east, and then I have my resultant from where I started to the end. Okay, so now what we need to do is we need to find out this triangle. It is a right triangle and we need to find the angles. So to find this side of the component, I know this is the hypotenuse, so it's sum resultant squared is equal to 2.4 squared plus 4.2 squared. Okay, so when I square those, add them, 2.1 squared plus 4.2 squared, and then I take the square root just to get the resultant by itself. I get the resultant vector to be 4.695. 4.69574. That is my resultant vector. Okay. I can have two significant figures, so this becomes 4.7 kilometers is my resultant. Now, I don't know the direction just well. What I would need, first of all, is this angle. So opposite over adjacent would give me that direction. Opposite, so the tangent of the angle is opposite over the adjacent of 2.4. Solving, I would get this angle to be the inverse of the ratio of the opposite to the adjacent. I got that from SOHCAHTOA, opposite over adjacent. Okay, I'm going to grab my calculator. And I put this in my calculator, 4.2 divided by 2.4, inverse tan. I get 60 degrees. Okay, so I have 60 degrees. Now we have to be very careful. It looks like we started from the north and we moved 60 degrees towards the east. So it's 4.7 kilometers north, 60 degrees east. Sorry, hopefully some of you had some red flags as I did this. It's not 2.4, it's 2.1, so that's going to change this to be 63 degrees. North, 63 degrees east. So just like in class, when I teach online, I make errors as well. 4.2 divided by 2.1.